the room.
All right. Welcome to this brief interview session with one of the speakers at the SecT conference, Ulf Frisk. Very welcome, Ulf. It was an awesome talk you delivered just recently here.
And the demonstrations.
The demonstrations. Oh, they are.
I mean, you can talk about these things, but you have to see them to believe them.
Yeah. I'm not kidding. It looks like black magic, really.
So we're talking about direct memory access attacks. And what is this horror?
Yeah, it's plug in an evil device into PCI Express on a computer, and PCI Express can be lots of things. And you pretty much gain full access to the computer unless the operating system has protected itself with the VTD.
Yeah.
So, and last year I talked here at SecT as well. I did 3 demos, and this year I thought it would be nice to do an extra demo. So I did like 4 live demos on stage, and they all worked.
They all worked.
They all worked. Yes, they worked very, very well. And let's. One of the topics was that you pwned all the operating systems, right?
Yeah, I started with an attack that actually Apple patched in last December, but it was quite fun because I could just walk up to pretty much any Mac that were in sleep or were locked, and if they were running the firewall to disk encryption, I could just plug in my evil PCI leech device into the Thunderbolt port, reboot the Mac, and get the full disk encryption password, and in less than 30 seconds, and that's like pretty evil. But Apple patched it in December, fortunately, so that one is a little bit old, but it's still a little bit fun to watch.
Yeah, and you went through it quite quickly, but so let's see here. So one level of, I mean, there's so many things which is automated in your demonstrations where the tool does so much, but I mean, the first level is that you're doing a DMA attack, right?
Yeah.
And the second thing is memory doesn't forget very quickly, so the memory remains.
Yeah. So basically the attack were that the Mac stored the firewall to disk encryption password in the memory, but Mac OS has been protecting against DMA attacks for a long time, so I can't really reach the memory where the password is stored. So I need to reboot the computer. The memory contents are still floating around for a few seconds before they're overwritten, but the VTD DMA protections are dropped in the reboot. So then I have a few seconds to read the memory, and once I read the memory, I can do some quick analysis on it, like live on stage, and get the password in less than 30 seconds.
So the memory remains, but the memory protection goes away. I mean, this is.
I mean, it used to be like that, but they patched it since December actually. So I would feel pretty secure if I were a Mac user now against that attack.
So what does the fix do? The
fix is they actually enables the VTD DMA protections very early in the boot, so even before they enable Thunderbolt, so I can't get into the memory.
So they fix the race condition basically.
Yeah, it's like total game over for my device, pretty much.
Well, that's good news for Mac users, but
unless you haven't set your firmware password then. So
yeah. Well, that's another problem. You demonstrated also a way to disable that in the firmware by using the safe boot or
so basically I was able
recovery
to
boot.
If I have access to the Mac in like 2 time occasions, I can, in the first occasion, I can reboot the Mac, go into something called a recovery mode, and disable the VTD DMA protections for Mac OS, unless the user has set a firmware password, because then I need to enter that password to go into recovery mode, and if I don't know it, it's like game over for my device. But anyway, if I do that and reboot the Mac, go into this recovery mode, disable the protections, if the user is running firewall to disk encryption, I mean, I can't get into it after that. So that's why I need to revisit the Mac in the future sometime then when the protections are off then.
Yeah.
And then it's like I go after the kernel pretty much, and once in the kernel I can do lots of various evil things in there, like taking total control.
So basically, lessons learned here is don't leave your laptop unattended in sleep mode.
No, I would say in the Macs nowadays, keep it updated and set the firmware password, and it should be totally secure against my attacks.
But when it comes to other operating systems, what's the status there?
Yeah, I'm still able to get into Windows as well, unless it's like running the virtualization-based security features with the device guard and code integrity. I'm still able to read parts of the memory down, and I can do a little bit of evil stuff, but not very much. I would say if you're running that setup together with like BitLocker plus PIN, you should be pretty secure.
How common is that?
I would say it's really rare, really. So it's,
so it's
probably the largest corporations are just starting to look at it.
Yeah.
It's stuff that's Microsoft provides to their customers. The customer is able to do that. But I would say it's really rare still.
Yeah, and if you look at Microsoft's pages, they still recommend that for ordinary users you don't set password. It's like high security option still consider. Well, it's not.
Yeah, but it is high security. I mean, normal users, they wouldn't run a disk encrypted disk either with BitLocker or whatever. So then there are easier ways to get into the operating system than using my stuff. So it's, it's a little bit high-end users that are worried about their security.
And I think when we talked to you last year, and you explained some of. And I think also you went more into the presentation there. How much chaining and things are needed where you do patch here and you patch here and you do a little bit of this to make the exploit work?
Yeah, I mean, I usually go after kernel, and I need to get code execution in kernel some way. And the kernel is not always directly reachable in the lower part of the memory, so I might need to abuse some other parts that I can gain, like code execution, for example, like a function pointer, or for example, as I showed in my presentation, I abused the UEFI runtime services to gain code execution in an EFI booted Linux system, for example. So there are lots of like chaining attacks, and it's a moving target, really. The operating system vendors are changing stuff all the time, and I'm trying to keep up and things like that. I know it's a battle that I will lose in the long term.
Because you will get tired eventually.
Yeah, no, because they will fix their stuff, just like Apple did.
Yeah.
They will like become totally secure in a couple of years, I would guess. But we are not completely there yet, and there are still legacy systems around for a long time. And
legacy hardware is delaying deployment, I guess.
I would say these kinds of things. I mean, the hardware that actually the operating systems and the firmware is making use of in order to protect against DMA attacks that have been around in hardware for so long time now. So I wouldn't say that the hardware part is really an issue. I mean, if you're running a really, really old computer, like pre-2010 or something like that, you're probably toast. But in more modern hardware, I would say that's not the issue. It's like that the vendors are not actually using the stuff that's in there in the hardware to protect against these kinds of attacks. And I mean, to be honest, it's a lot of drivers and things like that needs to be changed as well to be able to get a secure system and things like that. So it's not that easy for all the vendors to actually just make the change to become totally secure.
Yeah, I was thinking about there are of course a lot of evil scenarios where this could be used, like you're mentioning the evil maid attack. Someone wants to steal your information or implant something in your computer. But one thing that I was thinking about last year when you were giving the similar talk was the possibly good scenarios that you could use your technology to, like forensics, for instance, when you have a suspect's computer that is switched on, but it's protected and it might have encrypted drives, etc. And you want to catch that encryption key or the password. I know in the past you relied on basically luck if the memory was larger than 4 gigs. you were hoping that BitLocker key was in the lower 4 gigs of RAM, but when you demoed this last year, I was like, wow.
I mean, it's another tool in their toolbox, and whether it's evil or whether it's good, I mean, it's in the eye of the beholder, I would guess. It's another tool in their toolbox. It's not always working for scenarios that you're describing, but it might work. So it's and I would guess that it might be used that way.
Yeah. And of course, then came the Nsa Playbook, and this is basically the...
Yeah, but I built on the, if you're thinking about the Vol 7 leaks and things. And it was funny because this PCI leash, I built it actually on a device called the Nsa Playset Slot Screamer. It was the same device that was basically doing the same things, but lots of slower and things like that. Yeah. So I improved on that one. Really. Or actually I used the same hardware, I would say. Yeah,
that's also amazing. I mean, the speed at which you can capture memory using the PCI leash, it was on the demo, it was like 149 megs a second.
Yeah, sometimes I'm getting over 200 megabytes per second even. Wow. So it's
that's fast.
Yeah.
I mean, maybe not everyone is aware, but when I'm copying from an SSD, I get like 300 megabytes per second. So you're getting close to the performance of a fast media.
Yeah.
Well, do you know what's the limiting factor? Is it the card, or is it something with USB, or what would be the max?
It's running pretty close to its upper speed. I don't really know where the limit is, if it's like PCIe or if it's USB 3 or the drivers in there. But it's running close to its maximum potential speed. So I think that it's good enough.
Definitely good enough.
Wow! Yeah, it's an amazing, amazing tool.
Yeah, I mean, on a normal computer with like 8 or 16 gigs of RAM at 200 megabytes per second, it can take that much time to dump everything.
No, it's pretty fast. Once you get into the kernel, it's usually around, like, if you're running on an 8 gig system, 1.5 minutes. Or if you're like running on a 16 gig system,
I can wait 1.5 minutes. That's
it's
okay.
Like 3 minutes. So it's if you manage to get into the running kernel, that is. So it's and that could be a problem at some times, depending on the hardware and the setup and things like that. So it's of course, in my demos I shows the hardware that is, I know that they're likely to be working and things like that. So real life might be a little bit different, but I mean, I know some red teams out there that actually use this stuff and they think it's like pretty amazing, and it makes their work much easier. And I would definitely say it's something that you need to be aware of. And if you're like working at a big company or whatever, you need to be aware of that like attacks like this, they actually exist, and it's try to do something about it.
Yeah. Well, scary stuff, and as usual, an excellent delivery on your presentation.
Yeah, it was that all 4 demos were working. I was like, they usually work, but it's like you never know.
Yeah, the demo goes. Like
Yeah.
And you could see from the turnout in the audience after your presentation that you delivered a very popular talk. A lot of questions afterwards.
And I think while we were waiting, we discussed like, I mean, the tool is out there and the hardware is out there.
Yeah, but the hardware is like just sold out like a month ago, unfortunately. So, but I mean, there are lots of devices sold already. And but unfortunately, the hardware is getting harder to come by at the moment. So,
but I mean, theoretically, anyone can just go out this and they can run the tools. And but the thing is, you don't get the time to do it, and then you see it, and it's like when you see one system and you see the next system, when you see the next system, it becomes a little bit magic. This is like. This is what's still fun about security, that you can see like they do something and things happen.
Yeah, I mean, it's nice demos like that, and I was a little bit surprised actually. Since last year I did the same presentation or another presentation, but I own the same operating system pretty much. And I mean, that is still working 1 year later on. It's like, on the most recent fully patched systems. It's interesting.
It's awesome. So how many? I need to know how many hours of research did you put into this?
I don't know myself. I haven't counted it really. I would guess it's a lot.
Yeah.
So it's nothing you code in a weekend. It's like I put a lot of hours into this one.
Awesome.
And I mean, that's lots of tools like this. It's like people are just doing a quick POC or whatever, and they release it and they leave it, and it's like. But I tried to make a really user-friendly tool that everyone is able to use, and it should be like super easy for everyone to use.
It's like scary easy. I mean, almost click to pwn.
Yeah, it is. It's really click to pwn, or you need to run like one command line command, and then you mount the live memory as a virtual file in Windows that you're able to like open it in your favorite editor, and then you can click around in the file system and just right-click copy or whatever, which files you wish to copy from your victim computer or the target computer. So it's really user-friendly. I try to work really hard on that part.
I mean, we will forever be your fanboys. This is like, technology-wise, it's pretty incredible, and the delivery is awesome, and
the packaging is awesome.
and you're always very nice at explaining things, and
thank you.
Top marks on all points.
Thank you.
And I think one thing you showed was that you were actually able to, if you have a successful DMA attack, you could attack UEFI BIOS, and from UEFI BIOS you could attack Linux running kernel ASLR.
Yeah, I didn't actually. Yeah, I have an attack that's working against like the UEFI, like pure UEFI, after the operating system is started. That's like ongoing research. I didn't show that part, but I showed another part in the Linux, where the Linux kernel was loaded way above 4 gigs, that they are most likely to be, the kernels are most likely to be loaded in the very top of the memory or whatever in the more recent Linux versions. So I need to get to the kernel, and one way to do that is to actually patch into something called the UEFI runtime services, which is a part of the UEFI firmware that lingers around after the operating system is booted. And the operating system is calling into this firmware in order to perform special operations, such as get and set the EFI variables and set the hardware time and things like that. So if I'm able to patch that one, get code execution, if the operating system is calling into that one, I can get code execution on the CPU on the target system, and then I can patch the Linux kernel then, because then I can access all memory. And
when I was a young kid on the MS-DOS times, I was so amazed that I could do this like patching from a TSR and patch binary and things, and I thought I was so amazing. But then there was no technology, there was no security things.
Yeah, but this one is, depending on the system, I would say some Linuxes are really secure as well. So, of course, if you're running like cubes or something like that, it's not really possible to do things like this. Of course, I chose like a distro that I knew was going to work and things like that for my demos. And I would say on Linux, it's highly dependent on which distro you're running, on which kernel version. But things like
we have seen amazing demonstrations of cubes, but it's not really a widely deployed system. So I think the sort of interesting things are the distros with large user deployments.
Yeah, like Ubuntu and so on. Yeah.
I would say depending on the settings, whether you're running vice versa feature or whatever, if it's working. But if you just take, for example, like a live image or whatever, or an image, or just run it, I would say it's quite likely to be working together with PCI leash that the system will be vulnerable.
I overheard a question regarding BSD, but I didn't hear your answer. So would BSD be?
I looked into FreeBSD, and I even got PCI leash to work on version 9, 10, 11, I think it was. So I didn't research it further after that really. So I have a kernel module for it, but I mean I'm doing this on my spare time, and there are so many operating systems so much to do, and they're all changing all the time. So I don't really have time for all of them to give all of them.
So you're not necessarily secure just because you're running an obscure operating system.
No, not if you have like DMA attacks, and I mean DMA is like PCI Express. There exists PCI Express on other hardware than Intel hardware as well, for example on ARM and things like that. I know my stuff should be working there as well, like dumping memory and things like that at least, but I haven't really looked into those parts, so due to lack of time primarily.
Yeah, so I mean the complex thing isn't, at least after you have the hardware and the basic tools, the complex thing isn't really just doing the DMA, it's circumventing the IOMMU and getting...
if the operating system has configured it correctly, it shouldn't be possible to circumvent really, but it's like there might be some glitches in there and things like that, so it's...
Yeah. So getting past the security restrictions and solving all the problems to access memory outside of the 4 gigabytes limits.
Yeah. And I mean the 4 gig limit, it's actually a limit in the hardware that I use for the PCI Leech project, the USB 3380. In other hardware there are no such limits, so if, for example, I use like an FPGA DMA device, I'm very likely to be able to do pure native 64-bit DMA there.
Nice.
So having it working, but it's like really slow at the moment, so it's...
So work in progress.
Yeah.
Well, we're looking forward to hearing more from you in coming conferences. You have presented your work at both DEF CON and previously on SecT.
Yeah.
Any other appearances?
No, not really. I did like a DEF CON talk last year, and I did a demo lab at this year's DEF CON, and I did, as you said, the SecT talk last year. Actually won the Best Speaker Award. So thank you. Ja, nej, men tack för den.
Ja, tusen tack.
Jag tror att inte den måste ha varit avstängd eller något.
Nej.
Strömmataren. För nu lyser den. Ja.
Så där löste den förut typ.
Ja, den löser vi innan.
Men den måste ha dött väldigt sent in. Vi hörde ju några pip där, men... Ja.